Let me know. I think you can see my screen. Okay, I think you can see my screen. So today's topic is business intelligence. Okay, so what is it? We have the BI application. BI means business intelligence application. SQL is a small unit. SQL is being used, the SQL queries and all, it can be used in every aspect for on top of data. Okay. So suppose I have a BI application, maybe a system is there. In this system, we are collecting the source information. Maybe I am the business owner. I have a particular company. There are various shopping outlets. Okay, shopping malls over there for each location. Maybe for each city, maybe 10 or 20 cities. I have different outlets. So in each of the outlets, I'm collecting the information, the sales data into this BI application. And in this BI application, it's processing the data such a way so that at the end, the data engineers will be working on top of that. Such a way I can quickly get what is the sales in the previous quarter. This kind of question. Revenue growth in last 5 years. Best selling product in each session. Worst selling product for each of the outlet. Suppose I'm just giving a particular example. Uh, so this kind of question, I can quickly get it within 1 second if we have BI applications handy over here. Okay. So just like we know the rank function and all, we can rank it quickly based on what is the top growth. What is the top selling product? What is the least selling product? Maybe what is the reason why it's least sold in a particular outlet? Maybe I can also see that particular product is been moderately sold in another outlet. Okay, so we can check this kind of issue, and by checking this thing we can definitely increase the supply of that particular product for moderate selling outlet, rather it's selling into the old outlet. Okay, so this is the BI application, and it's representing this kind of questions answer. Now, what is inside BI application? We'll be learning this thing after a few slides. I'll be just giving some more concepts. So, what is the BI cycle? Business intelligence cycle. It's a closed loop. You can see over here. So, it's taking data from OLTP. This is the source system. OLTP. What is OLTP? I'll be coming. OLTP is a source system from where we are receiving data. So, especially how the data in OLTP comes, that thing we no need to check from data engineer's perspective, but it is also required for some cases, but especially as of now we can ignore it. How OLTP systems data can be populated? Maybe suppose when you are entering data, when you are purchasing some product, a invoice is getting generated, a product, on your customer IDs against a particular record has been generated in the database, because there are some data entry. You can see in computer they are mentioning something. They are registering your mobile number, your name, your what product you have purchased, this kind of stuff. Maybe you are giving also some feedback over there. They're also storing the feedback. Okay. So in OLTP system, we are receiving all those kind of source data. Okay. Now, as the data engineers, our comes should be starting from here. We should be loading the source system data by ETL tool to data warehouse. Okay. What is ETL tool? I'll be coming this thing later. Just a quick concept. ETL means extract, transform, load. Okay. So it is extracting the data from here. We are transforming the data based on our requirement. What is the requirement? Maybe the data type, it should not be this manner. Maybe we need to calculate something more. Okay. Based on the source thing, we need to derive some more columns. Okay. So that's the transform. E means extract, T means transform. Load means load the data over here in data warehouse. DW means data warehouse. So all the cleansing data, all the transforming data, those are being stored over data warehouse. Okay. And it's prepared for reporting purpose. Reporting charts, graphs, list. I mean, lots of reporting graphs or charts are available there. So on top of data warehouse, the charts, graphs, everything are being presented. So when it's been done, the decision owner means the business owner. They can take the easy decisions, what to go with, or what particular changes is required, or what strategy they need to take in future to make their revenue a bigger one. Maybe they are facing some losses. So they can, they can check what is the reason of the losses by this reporting. On top of the tables data, the charts and graphs are prepared and they can able to check what is the main issue with their losses and all. Based on that, they will be taking the strategy and they will be inputting the same thing to the business ideas over here. Maybe just like I told you that the list selling product they will be removing from that particular outlet and they will be transferring it to the moderate selling outlet. That product should be sold over there. There will be no losing of the product because a particular product should be having expiry date and all. So if a particular is not being sold within expiry product, that is the loss of that particular company. But that can be sold if we just have a good strategy to transfer it to some other location. Okay. So this kind of business strategy they can take over here. And in the very next day or after few days, they can check the improvement in the reporting. So every day, daily basis, we are receiving the source systems data over here. The ETLs are running. The data are getting transferred over here with proper cleansing and transforming operation. Then on based on some reporting tool, we are creating the charts, graphs, and everything. Okay. On top of those charts and graphs, business decision makers, they can take easy decisions or they can take easy strategy. What should be our next move? And they are implying the same thing into the source system over here. So this cycle is going on and going on. Any doubt from anyone? This is the overall concept. Maybe we are working in a small thing. Maybe as a developer or as a support member, we are working as a in an ETL tool, maybe a reporting tool. Okay. Maybe we are working in the data warehouse, creating data modeling, this kind of stuff. Maybe the decision strategy, they should be owning the company. Maybe they are specialized in MBAs and all. They know the business administration well. So they are taking easy decisions. Okay. Any doubt from anyone? Nothing? Okay. Moving to the next slide. Okay. So here it's OLTP. Now, what is OLTP and what is OLAP? So especially as of now, you can see this is OLTP system and OLAP, it's been stored over here in the data warehouse section. This is mainly OLAP is ready for the analysis purpose. OLTP means online transaction processing system. Whatever at the transaction level, we are storing the data in the source system. That is the OLTP systems. So OLTP is online transaction processing systems are the class of system that can manage, facilitate, and support the operational or transaction oriented applications. For example, banking transaction, we are doing some banking transaction. So immediately it's been stored in a OLTP system. Sales transaction in a retail store, railway booking and cancellation. Uh, those are the things which are called OLTP systems. What is OLAP? Just I told, when the data is ready in the data warehouse, okay, it's been ready for the analytics or analytical processing system. Okay, so when it's ready for this thing, so that storing thing, it's called OLAP, Online Analytical Processing Systems. Are the class of systems that are used to analyze information. This typically requires large volume of data. OLAP systems have relatively low volume of transaction. OLAP systems are designed to handle complex queries that are used to discover trends and new patterns. There is some hidden trends in your business. By checking overall data, you cannot able to see it. But when you are creating the OLAP and you are doing SQL queries, your analysis, we are doing some analysis on top of the data, then you can get those hidden pattern, hidden trend. What is the trending of the data, the forecasting of the business and everything. Okay. So from OLTP system, we are loading the data in OLAP system. That is the entire overall fundamental thing. And just a quick introduction, what is decision support system? It's the end user, rather we can say, who are owning the businesses and all. Okay, so what is the sales distribution region wise? How much profit does a particular product contribute? How can promotions be better targeted for greater leverage? How did my revenue improve in the last 5 years? Okay, so those can be quickly answered, and the decision support system can take easy decisions. They can take on those decisions. Maybe there are new questions arrived in the decision maker's mind for for their goal achievement of the company. So that is why the decision support system, they can took easy decision on based on those questions, and that can be answerable from the OLAP data, or rather we can say the charts and graphs created on top of the OLAP data. So just a quick exercise, I mean example over here. We are receiving this kind of data, we are processing it in OLAP, and on top of this data, we are creating charts and graphs in this manner. Okay, and how much easy to check this thing from decision systems. They're checking this thing and they're taking easy decisions on top of data. A world without DSS, this kind of thing should be happened. Data is spread across the organization, but there is very delayed of accessing the data. Uh, so business user spends too much time on IT tasks. Okay, so also that is why DSS should be. I mean, the particular requirement for DSS is much more important over here. Okay, now I'm moving to the data warehouse part where we are storing the data from operational transaction system by ETL tool. So just like a quick overview or flowchart, again from the beginning, whatever we have told till now, data entry operator, that means in a shopping outlet, you can see someone is entering the data by typing all of your information, your name, your mail ID, your phone number and all. Then what particular products you have bought, is there any discount been available there, uh, your rating on top of the product, how much frequent the particular product you are buying. So this kind of all the things are been, I mean, they are storing the basic information, but in the analytic systems, this kind of logic they're implementing. So you are maybe uh, you are getting some discounts. Maybe if you are not purchasing any product for 5 or 6 months, they are giving you some offers on top of some products. So yeah, anyone is telling something? Okay, I think it's a noise. So if there is any stuck point from anyone, please ask me the questions. Okay, so I'll be just coming, the data entry operator, they're pushing the data in the operational database. Those are transactional information. Okay. The data is extracted during non-business hours. So when the business day is closed, at the night time of the business day, the data are getting loaded into data warehouse. Okay. So it's been done daily basis. Some new information might be coming in tomorrow. So that should be also storing it over here. The new information should be coming over here. This thing will be also storing over here. But it's not erasing the previous day's data. So there is lots of concepts of data warehouse. So it should be storing the historical information. Otherwise, we cannot get what is past 5 years revenue or what is the slope of growth. Okay. So data warehouse is a big memory size. It's storing the historical information as well as the new information coming daily basis. It's the ETL tool, it's loading the data, and then the reports are being generated, and DSS, decision makers or managers, they're checking the report and they're taking the decisions for the next day strategy. Okay. It's the same thing with a different pictorial representation. Moving to the next slide. Okay, that's the thing I was mentioning. Data warehouse, it should be subject oriented. A data warehouse should be created for a particular subject only. Okay, data warehouse, just like it can be a database, the same kind of database that we are checking at the MySQL side. Maybe a collection of lots of databases is a data warehouse. Okay, in the data warehouse we can store the data in tabular format. Maybe there are lots of tables just like product information for employee, outlets employee information, for particular customer information you're also storing the customer information, the transaction details, the billing information you're also storing over there, maybe in a billing table. Okay, so all those kind of tables we are creating in the data warehouse. It is subject oriented. We are storing the information based on particular subject over there. It should be integrated in nature. It should be time variant. So we can take data from past. The last one is not non-volatile. So it cannot be erasing data until as per the decision or business choice. Okay, business wants to delete archival data, maybe last 10 years data, they do not want to keep it because you are storing the data, it's taking some capacity or and taking some spaces in the server, and it's been charged by the same way from the, maybe we are adopting some cloud. Okay, in the cloud we are hiring a database to store our data warehouse. Okay, so data warehouse is having, it's taking maybe teradata of information, teradata or GB, gigabyte related information. There are hundreds of millions rows are available for each of the tables. So lots of memory it's taking. Okay, each of the tables they are taking lots of memory consumption. So by this memory consumption, a lots of money they need to spend to the particular cloud host, that I'm taking this much storage, so I have to pay this much. So then they need to check, if we just delete previous maybe to from 1990 to 2010, we do not require this much record as of now, we can eliminate this thing. No need of the business strategy to take this kind of data, and we can delete this thing. We can easily delete this kind of steps. Okay, but it's non-volatile. Without our choice, nothing will be deleted over there. If we only choice, if the business choices to delete the thing, then only it can be deleted. Otherwise, it's non-volatile. It will not be erased randomly. It should be always volatile. Non-volatile. Okay, again, detail level data warehouse architecture over here. with some more layers. So those are the various source system, or rather we can say OLTP systems. Okay. So doing a ETL tool, by using the ETL tool, we are storing those data into staging layer. Okay. From this staging, we are loading the data in ODS. What is ODS? I'll be coming. It's a new field, you can see. It's been introduced over here. And we can store ODS. It's an optional thing. We can store in data warehouse. Both of the things are being used as a OLAP analysis. Okay. And you can see data warehouse can be splitted into data marts. It is the miniature of data warehouse. Based on each of the subject area or sub-subject area, we can create data marts from data warehouse. Okay. So this is the overall things in a particular data engineers, they need to know that stuffs. It's a basic thing. And all the blue color thing, it's the ETL tool. We are loading data from one system to another system. Maybe this is a different system. Maybe a mainframe system is there. This can be a flat files, lots of Excels in a different Linux server. Okay. So there are various source system. Different kind of sources data are coming over here. So first ETL tools are loading the data into staging area. They're staging all these things, different kind of sources into a single database, a single stage area. Okay, this is the first step of ETL tool. Then we are cleansing and transforming it. That means ETL. We are transforming the data over here to and loading into data warehouse. Okay, so we need to know specifically as a ETL tool, what is ETL tool, how to load the data from source system to targets and all. Then we can also use the SQL queries over there too in the ETL tool. Suppose I have to fetch some columns from a particular database over here while extracting the information. I do not need all the columns. Suppose we need the entire tables to be loaded. There you need to use select star from this table. Okay. So just a quick thing. What is ODS and what is data marts? Those are the new things coming into the picture. Data marts is nothing but it's a similar kind of data warehouse. But ODS, operational data store, it may be there for some BI application. It may not be there. It's not the important steps, but it is mainly used for real-time data. And it's very much fast. So suppose in the previous example, I told you, whatever transaction it's happening today, the transactions are being stored into the data warehouse in the night time. It's non-business hours. And the charts and graphs are being populated with the new data, and that charts and graphs can be visible to the end user in the very next day. So whatever transaction is happening today, that cannot be included in the same day's charts and graphs. Rather, user can see this data, reflected data. The new output reflected data can be visible in the very next day. Okay. So it's called, operational data store. It's a different thing. It's analyzing real-time data. Means if there is any update at the source system, it's quickly updating the same thing in ODS, operational data store, and it's producing the correct output. So solve day-to-day problems. Okay. And the data mart is simple, just like same thing in the data warehouse, what we have learned. It's not reflecting quickly. A data warehouse just like, let me just show you this thing. A data warehouse contains data from multiple subject areas, departments in an organization. Our data mart is a simple form of data warehouse that is focused in a single subject area, maybe a single department, is being stored in data mart, or single functional area such as sales. For sales we have a data mart, for finance we have data mart, marketing part another data mart, but entire things have been stored in a single data warehouse. This is the concept. So data marts as a miniature of the data marts, a miniature of the data warehouse. It's a subset of data warehouse, nothing else. Again, a representation of things. OLTP system. This is property insurance data. It's been stored in property data mart. We have an insurance company, OLTP system. Okay. There we are storing property related information. We are storing automobile related information. We are storing commercial information. Each of those thing is being stored in different data mart. Okay. On top of this, we are creating charts and graphs. So each of the specialists, they can take easy decisions based on each of the data marts data. Okay. Now in the data mart or in the data warehouse, how we are storing the data? I told you it can be in tables. Always it can be tables. But the tables can be either fact or it can be dimension. Okay. So the fact table, what is fact? Facts answer these questions. How much or how many? So basically, I just want to mention whatever tables we are storing in the data warehouse, in the database, that can be a fact table or that can be a dimension table. Okay. So now what is fact and what is dimension? Inside fact table, what can be stored, and inside dimension table, what can be stored? This is the concept I'll be just providing now. So in the fact tables, all the facts related information can be stored. What is facts? If we question on top of data, how much, how many? So whatever answer I'll be receiving, it should be stored in fact. Just like uh, it's a measures or numerical value. What is the revenue? What is the cost of this product? What are the number of the accounts that have been stored in particular banking industry? So those kind of questions, those are giving a numerical answer. Those are called fact. Okay. Inside fact table, we are loading those facts, obviously. The red color highlighted one. You can see. But there is also some black color columns. This is a table, okay. Sales table, this is billing table. Inside sales tables, those are different column. Date key, store key, product key, then sales, quantity sold, price, discount for sales table. Inside the sales tables, you can see the below four sales column, quantity sold column, price column, discount column. Those are facts. And the upper three, those are keys. I have told you what is primary key and foreign key. If you can remember, for this fact table, most of the things should be foreign key. So it will be setting up relationship between other dimension tables. In those, each of the dimension table, there should be a primary key. There is a date dimension table and date key is the primary key. There is a store dimension table where store key is the primary key. There is a product dimension table where product key should be the primary key. So this kind of foreign keys are required in fact table, especially to set up relationship between dimension table. Now what is dimension table? I'll be coming. Just to quickly repeat the topic. Fact table should contains all the fact related information. In addition to it, it will also store the foreign keys for different dimensions. Now coming to the dimension. If we question on top of data, who, what, when, where. So whatever answer I'm receiving, Those are dimensions. Just like customer, time, geography, those kind of things are there. In the previous example, we have seen stored key in the particular fact table. Now this is the dimension table. In the stored dimension, all the store related information should be stored over here. Store key, store name, street address, city, state, region, country. In the product table, product key, product ID, product name, product group, brand, department, those things are there. But should be having a primary key. This is a stored key in the store table. In the product table, we are having product key over there. So based on this primary key and those foreign keys, we can set up relationship between fact and dimension table. But in the data warehouse, we have to store in this way. Fact should be inside fact table and dimensions should be inside dimension table. Okay. Yeah. As of now, those are all. We have created fact and dimension. In the very next day, tomorrow, we'll be learning how to create data modeling. I mean, based on those facts and dimension, we need to set up the relationship properly so that we should be having a data modeling and we can take easy data. I mean, whatever data is required, we can fetch it from there. And what are the next steps of the business intelligence and all? What are the different reporting stuffs? Some important terminologies we'll be learning in tomorrow's session. So, business intelligence day one, is there any doubt? Whatever we have checked over here, whatever we have learned today, anything from anyone?
No, Nandi, I'm good at the moment.
Okay,
Nandi, are we going to cover Python as well as part of this session?
correct. So Python will be using as a ETL tool over here. So in the blue color, you can see
Okay.
we are extracting information from the source system and transferring it and loading it to the target system. So in Python, we'll be learning how to do that. Python can be used as a ETL tool. In tomorrow's session, I'll be showing you there are different ETL tools are available in the market. And nowadays, open sources language just like Python, Java, we are also creating some framework which is being used
Mhm.
as a ETL tool. Okay, so this kind of things
Okay.
I'll be introduced tomorrow. And before after the business intelligence chapters, we can cover. You can start the Python. There are 5 to 7, and there are 7 days for Python allotted for Python learning. 2 days for the basic things, and after that, we'll be learning Python as a data engineering stuffs. Okay.
Okay. Are you going to cover R language as well,
No,
Nandi?
no, no. As of now, we'll be only
No.
covering Python as a
Python.
ETL tool
Okay. Okay.
in this
Okay.
session.
Okay. Okay. Okay.
Yeah. Any doubt from any other? Okay, I received one chat. What about Scala? Yeah, Scala is also a scripting language. Scala scripting. It's similar kind of stuffs in Python. Okay. It's some difference is there in I mean whatever we will be learning for Python. So for Python, we will be learning the thing from the basics and trying to cover for data engineers. Scala will be covering in maybe in Hadoop chapters. Okay. So when we'll be learning Spark, so I'll be showing you some code snippets or try to have some hands-on top of Scala scripting. But it's similar kind of stuff like Python. If you learn Python completely, then it will hardly take few days to learn Scala only. Okay. Scala is just like similar kind of stuffs like Python as per the language perspective. Okay. Any other thing from anyone? Okay. Okay, then I hope nothing as of now. Let's connect tomorrow for the rest of the things for business intelligence. It is very important because you are checking overall things. If you're already having experience, then you might have know what all those things. But maybe I'll be just revising this thing. But if you're totally new and you are going to get a job, maybe you are getting a new role, maybe a ETL developer, maybe a data analyst or anything, but you are not checking the overall picture, what you are doing. and how much important your work is. Okay, and how you are going to be benefited for your company, and what is your role, how the data is being shown to the users. So this kind of overall things have been covered over here. Okay, so that's all for today's session. Let's connect tomorrow for the rest of the stuffs of business intelligence. Thank you, everyone. Bye bye.
Bye
Uh,
bye.
Good night. Yeah, bye bye.
Bye bye.